In this tutorial, a simulation in the canonic ensemble, that is, the NVT ensemble, is carried out by Monte Carlo. We are going to use the ms2 PAR application, which is included in the ms2. SI units or reduced units may be used. Note that this only affects the input values of the state variables in the parameter file. The reference length has to be entered in angstrom. The reference energy has to be specified in kelvins, that is, divided by the Boltzmann constant. The reference mass has to be entered in atomic mass units, that is, in gram per mole. We're going to perform a Monte Carlo simulation. The target acceptance rate of Monte Carlo moves has to be specified. That is, the maximum displacement is adjusted by ms2 during equilibration. Choose NVT for a canonic ensemble simulation. Enter the number of NVT equilibration Monte Carlo loops. Note that a loop contains a number of Monte Carlo displacement attempts that is equal to the total number of mechanical degrees of freedom. So for a simple case of n rotationally symmetric molecules, it is 3n. Enter the number of production loops where the thermodynamic properties are actually sampled. Specify the frequency by which the running average file is updated. Note that this also specifies the frequency with which the run file is updated. This specifies the frequency how often the result file is updated. This specifies the frequency by which the configurations are written to the Vim file for later visualization purposes. If you specify it to be 0, no Vim file is written. It is advised to use a center of mass cutoff scheme. This scheme is preferred because it is much faster than the site-site cutoff mode. It is advised to use the reaction field method for the long-range corrections in case of dipolar fluids, unless ionic systems are simulated. In this case, Ewald summation is the appropriate choice. Specify the temperature, the density, and the number of particles. To specify the underlying molecular force field model, load the potential model file. Here we have chosen H2S. You can make changes in the potential model file in this tab if you wish to. However, we do not advise to do this. Here you can specify the method which is used to calculate the chemical potential. We will calculate the chemical potential with Widdom's test particle insertion method. The gradual insertion technique, which is an alternative, is only recommended for cold and particularly dense liquids where Widdom's method fails. The number of test molecules for Widdom's test particle insertion method has to be specified. A good rule of thumb is to enter a value that is 3 to 4 times as large as the total number of real particles in the system. Here, the cutoff radius has to be specified. Note that the cutoff radius cannot be larger than half of the length of the simulation box. If you enter a negative number like -1, then the cutoff radius will automatically be determined to be 90% of half of the length of the box. The dielectric medium constant for the reaction field method can be specified. If you want to use tinfoil boundary conditions, choose a very large number that approaches infinity. Execute the simulation on the basis of the PAR file with the ms2 executable. Once the program starts, the following output files are generated. This concludes the introduction into Monte Carlo simulations in the canonic ensemble.